Welcome to day 12 of top 100 most asked network engineer interview question and answer series. Guys, this is day 12 of top 100 most asked network engineer interview question and answer series. Till now we have discussed 55 questions and today we are going to discuss 5 more important questions. Okay, so without wasting our time, let's begin. So first question for the day is this one. In this scenario, this is a scenario based question, right? Interviewer is asking scenario based question as well in interview. That's why I mentioned this question here. So question is, in this scenario, if all the ports of both the switches have a bandwidth of 100 Mbps, then which port will be blocked? So guys, as you can see over here in this scenario, we have two switch, right? Out of this switch, one switch will become root bridge switch. One switch will elected as root bridge switch. So which switch will elected as root bridge switch? Which has lowest bridge ID or which has best bridge ID. So what is bridge ID? Bridge ID is combination of two things, priority plus base MAC address. So by default priority on switch number 1 is 32768 and over here as well 32768. So priority will be tie, so they will check lowest MAC address. So here MAC address is 00D and here MAC address is 000. So definitely switch 2 has lowest MAC address, so switch 2 will become root bridge switch, right? So this switch will become root bridge. Okay, after electing root bridge, right, all port of root bridge switch will become DP, designated port, DP, right? And on switch 1, out of these two ports, one port will become DP and one port will blocked. So which port will become DP? Switch 1, on switch 1, actually I am talking about switch 1 now, right? There is no role of switch 2 now. So guys, actually when switch 2 will receive superior BPDU on this interface as well as on this interface. So switch 2 will check on which interface I am receiving superior BPDU. So this switch will compare first designated bridge ID. So designated bridge ID will be same in the both BPDU. After that this switch will check cost. So cost will be again tie because both link has bandwidth of 100 Mbps, right? Then this switch will check sender port ID or you can say designated port ID. So on this interface, on fast Ethernet 0/0, what will be the sender port ID? Sender port ID will be fast Ethernet 0/0, and on this interface, sender bridge ID will be fast Ethernet 0/1. So now switch 1 is receiving superior BPDU on this interface. So this interface will become RP, root port. Guys, DP is a port on which switch will transmit superior BPDU. And reported port RP is a port on which switch will receive superior BPDU, right? So now switch 1 is receiving superior BPDU on this interface. So this interface will become RP and this interface, this port will blocked, right? This port will be blocked. So this is your right answer, right? Switch 1 fast Ethernet 0/1 will blocked. Okay, now let me move on next question. And always keep in mind what is designated port and what is reported port. So a port on which switch will transmit superior BPDU, that port will become designated port DP, and a port on which a switch will receive superior BPDU, that port will become RP, reported port, right? So which switch will transmit superior BPDU? Root bridge switch. So this is my root bridge switch, right? Switch number 2 is my root bridge switch. So this switch will transmit superior BPDU from this interface and from this interface. That's the reason why this interface will become DP and this interface will become DP, right? On this interface, this switch will receive superior BPDU. So that's the reason why this interface will become RP and this interface will blocked. Okay. Now let me move on next question. Question number 57. And question number 57 is this. What are the different port states in STP? Port states. So guys, there are 5 port states. There are 5 port states in STP. First one is disable, second one is blocking, third one is listening, fourth one is learning, and fifth one is forwarding, right? So you can say disable means a port where you are not running STP protocol, right? That simple access port, that port is known as disable port in STP, right? Actually we are not running STP protocol on that port, right? So that port will be considered as disabled, right? After that, blocking. So when you will configure STP on any port, right, the port will move from disable to blocking, and within 9 they will move from blocking to listening, right? And in listening state they will spend 15 seconds, right? They will spend 15 seconds. After that, after 15 seconds, the state will be moved from listening to learning, and in learning state they will spend again 50 seconds, right? After that they will move in forwarding state. So what is the difference between disable, blocking, listening, learning, and forwarding? So guys, if I talk about disable state, right? So in disable state, a port can't receive BPDU, or can't transmit BPDU, or can't learn MAC address on that particular port. So you can say disable port means a port is down, right? Port is administratively down, right? So that port will not send data, that port will not receive data, so that port will consider as disabled port, right? If I talk about blocking port, so blocking port is a port on which BPDU, a port can receive BPDU, right? When a device is connected, the port will first enter in blocking state. Now in this state, a port can receive BPDU, but a port can't send BPDU, can't transmit BPDU. That port can't receive data, that port can't send data as well, that port can't learn MAC address, right? If I talk about listening state, in the same way, in listening state, a switch can transmit BPDU, a switch can receive BPDU, but switch will never send data. Switch is not able to send data in listening state, right? And not receive data in listening state, and switch will not learn MAC address as well. But if I talk about learning state, so in learning state, switch can transmit BPDU, switch can receive BPDU, switch will not send data, switch will not receive data, but that port, on that port, switch will start learning MAC address. Switch can learn MAC address on that port, which port is in learning state. And last one is forwarding state. In forwarding state, switch can forward data, switch can receive data, switch can forward BPDU, switch can receive BPDU, switch can learn MAC address, right? So this is your final states, right? So these are 5 states, very important question, right? Very important question. Many times interviewer is asking this question. So if I talk about disable, so in disable mode, a BPDU can transmit, no. A BPDU can receive, no. A data can transmit, no. Data can receive, no. Can MAC address will learn on this interface, no. If I talk about blocking, so blocking, BPDU can send, no. BPDU can receive, yes, right? BPDU can receive. Data can send, no. Data can receive, no. MAC address can be learned on that port, no. If I talk about listening, BPDU can send, no. BPDU can receive, yes. Data can send, no. Data can send, data can receive, no. MAC address can learn, no. If I talk about learning, so BPDU can transmit, yes. BPDU can receive, yes. Data can be sent, no. Data can be received, no. MAC address can be learned on that interface, yes. If I talk about forwarding, so BPDU can send, yes. BPDU can receive, yes. Data can send, yes. Data can receive, yes. MAC address can be learned, yes. Okay. So these are the 5 port state in STP. Okay. Now let me move on. Next question, question number 58. And question is explain root guard in STP. Guys, what is root guard? Guard means something like security, right? If I talk about guard, then guard, what is the use of guard? To protect something, So as explain root guard. So as a name, it is a root guard, right? So this guard is responsible to protect root bridge, right? This guard, root guard, is responsible to protect root bridge. Okay, so you can see over here, root guard is used to protect root bridge. Root guard is used to protect root bridge. So actually what will happen if suppose we have some switch number 1, switch number 2, switch number 3, okay, and these are connected together. Suppose MAC address of this switch is 0A, MAC address of this switch is 0B, and MAC address of this switch is 0C. So this switch will become root bridge switch. Am I right? Now if there is one free port and attacker will come with their switch and they will connect their switch on this interface, and if they will set priority 0, less priority, so this switch will transmit BPDU, and when switch will receive BPDU on this interface, they will check is this BPDU is superior BPDU, so definitely priority will be 0. So this switch will came to know that I am receiving superior BPDU on this interface, so this interface will become RP, right? And this switch will relay that BPDU to switch 1 and switch 2, right? After that, switch 1 will came to know that no, now I am not root bridge, no, root bridge is this switch, right? Attacker switch. Fine. So to stop this type of attack in your network, we are using root guard. We have a feature called root guard. So root guard is used to protect root bridge. Root guard stop a new switch to introduce in the network with the lowest bridge ID to become a root bridge, right? After that, if a port with root guard feature enabled receive a superior BPDU, it will move the port into the root inconsistent state, right? So when suppose this is my switch and here is one more switch, suppose this is my switch 2 and this is my switch 1, MAC address of this switch is 0A, MAC address of this switch is 0B, so this is my root bridge, and here if attacker will attach their switch with MAC address 00, right? Suppose this is switch 0, then this switch will transmit superior BPDU, right? When this switch will receive this BPDU, this switch will came to know that this switch is my root bridge. This switch will become root bridge because it has lowest bridge ID, or it has lowest root bridge ID. Am I right? So this switch will become root bridge. So to stop these things, you can see if a port with root guard feature enabled receive a superior BPDU, it moves the port into the root inconsistent state. So now whenever a port where we configured root guard, on that port if a superior BPDU will receive, then that port will move into root inconsistent state, and root inconsistent state is similar to listening state, and in listening state we can't send BPDU, we can't send data, right? We can't learn MAC address, right? So how to configure root guard? So command is very simple. Go to interface, after that spanning tree, root guard. So if I will configure root guard on any interface, on that interface if switch will receive superior BPDU, so that port will move into root inconsistent state. Okay, now let me move on. Next question 59. Question number 59 is explain a spanning tree port fast. So guys, actually as I told you, in listening state and learning state, right, they will spend 15 seconds, switch will spend 15 seconds in listening state and 15 seconds in learning state, right? So whenever a port will come up, right, so how much times they have to wait to forward data? 30 seconds, 15 seconds for learning state and 50 seconds for listening state. So every time user have to wait for 30 seconds, right, to forward data. So to resolve this problem, we have concept of port fast. So you can see over here, port fast is an enhancement feature of STP, which speed up the STP convergence on access port. So actually we configure port fast service on access port so that it actually causes the spanning tree forwarding state immediately by passing listening and learning state, so that if you will configure port fast on access port, so they will pass learning and listening state, so immediately they will move in forwarding state. That port will move in forwarding state immediately, right? It is used on access port only where a single workstation is connected, and command is go to a spanning tree port fast. You can write this command or on the interface. This command will work on interface, or you can say you can write this command to configure port fast on all interface, all access port, right? All access port, on all access port. A spanning tree port fast default. This will enable all the access port in port fast, or this command will work on interface. Okay, so this is port fast. This is very important question. Night time interview is asking this question as well, right? Now let me move on last question of the day, question number 60. Question number 60 is explain BPDU guard. So again, guard is a protector, and this guard will protect BPDU, right? Root guard will protect your root bridge, and BPDU guard will protect your BPDU. So when we enable port fast on a port, right? When actually what will happen, understand with one scenario. Suppose we have switch 1, switch 2, okay, these are connected like this, so one port is blocked, okay, and suppose this is my access port. This is my access port where I configured port fast. After that, if attacker will attach a switch on this port, what will happen? Actually, when you will configure port fast, right, on any interface, when you configure port fast on any interface, that means you stop STP on that interface, right? That port will not participate in STP election. So if there is no STP running, that means whenever a switch will connect on that interface, then when switch will send a broadcast message, then again loop can be created there, right? Am I right? So suppose this is my scenario, this is my switch 1, and here is some PCs. So I configure this port as port fast, right? So that means I am not running STP on this interface. So if attacker will remove this PC and attach a switch over here, and if they will send BPDU, right, and suppose there is one more link which is connected to this switch, so again there will be loop, there will be a loop can be formed, there, right? Because here you are not running STP. Actually this port is considered as port fast, right? So guys, what is BPDU guard? When we enable port fast on a port, we do not expect BPDU on that port, right? Actually we do not expect BPDU on that port. So in case a switch is connected by mistake on the port where port fast is enabled, okay, by mistake, if we will connect a switch on a port where port fast is configured, a loop can be formed, right? It's clear till now? A loop can be created. Okay, since when we configure port fast, we disable STP on that port, right? Till now it's clear. So to protect from such scenario, we can enable BPDU guard on the port, so that once a BPDU is received on a port fast port, if a switch will receive a BPDU on port fast port, the port will move into error disable mode, right? And error disable mode is similar to shutdown, so that port will shut down. So whenever you will configure a port as port fast, then you need to configure that port as BPDU guard, on that port BPDU guard as well, so that if someone will attach switch or someone will connect switch on the port on which you had configured port fast, so that port will move into error disable mode, right? So if you will not configure BPDU guard service on a port where you are running port fast, and whenever switch will receive any traffic, then there is a chance of loop, right? Loop can be formed there, right? Because if you are configuring port fast, that means you are disabling STP on on that interface. Okay, so this is 5 most important question. In next video we will discuss 5 more questions. That's all for today. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. Thank you. Thanks for watching. Bye bye.